into the instruction, I also gave you, well, let's take a look at this file, assignment 05, and I also give you the final versions, assignment 6, the demo. And in addition to this demo, there is an IR file. We are going to use another charting component. The charting component is a commercial version. It's called T-chart. Although we have been using the Microsoft chart, right? But the Microsoft chart can deal with simple, 2D charting only. But as you can see, I mean, in probably the chapter 7 or chapter 4 of our textbook, we need to display our output response in three-dimensional space. But our Microsoft chart cannot display real three-dimensional charting. So we need to take advantage of using another one. And unfortunately, we do buy. We have spent a lot of money buying the source code or T-chart charting component. So I will introduce you probably in this assignment or next assignment. Probably I cannot make sure if we should do that. But I'll also give you a demo application. That should be the final version, because the ultimate goal we would like to have is that we can the user create a fuzzy inference system, including all those three kind of fuzzy inference model, Mandanis, Scanner, and it's Komodo's model. I think it should be in the chapter 4. So we need to make these modeling functionality complete at the final project. That should be the assignment 6. But for now, for this assignment 5, what we need to just let the user specify the fuzzyIfThenRule and also provide the inferencing capability for the user anyway. So instruction is here. That should be the assignment 5. And before we read it in detail, let us show the final versions of this fuzzy inference system by using this demo application. So this is the demo application or the final project, right? And this project to take, we need to put another library. We call it tchart.dll. So this program can run only the tchart.dll is ready in the same directory. Because to make sure for that, probably in assignment 5 we will include this tchart, or probably in assignment 6 later on it will show. So that is the final. When you complete assignment 6, it's a complete application. We can let the user select whether it's a Mandani or Scanner or Komodo fuzzy inference system. And the user can interactively use this interface to construct, to build up an inference system. That is the purpose of the final assignment. So let me broadcast it. So as you can see, if user select Mandani fuzzy set, if you use select Scanner model will be a little bit. See the difference right here. We kind of will have a tab pages, the user interface right here, right? But if you use a spatial scanner, then the output is not a fuzzy set. Output should be equation. So if you are familiar with the so-called dynamic compiling, so C# programming language, actually we can let the user write a code talking about the function or the output or the output equation by writing a piece of C# programming code right here, and then ask the application to compile it. In the runtime. But right now it's really troublesome to add in this kind of functionality. So our code somehow our output scanner model, our output equation has been hard coded in our system. So we let the user anyway choose each one of the choose output equation from the pre-coded or hard-coded equation right here. So that is for the scanner. If it is not scanner, well, it's okay. If it is Mandani fuzzy inference system, we just let the user select the output fuzzy set from where? From the tree, right? with the tree, you're gonna see it anyway. So for the assignment 5, we needed to let the user specify the if-then rule. But as you can see, we kind of encounter a new control. We will call it data review. Later on, I will show you how to access this. So eventually, user will. So for this tree view, which is right here, we also have indicated that in this first level, there are simply two options. One is input universe. You cannot add it. Output universe. If a user click on input universe, okay, add a input universe. How about output universe? Output universe is just one. You cannot add a multiple output universe, right? So for the input universe, so user, once you click on the input universe, then this button is available. So user kind of add the input universe. So if it's multiple is antecedent, so user can again specify well x2. How about output universe? Output universe only has one universe ready. So once user click on output universe, if user try to add another output universe, it is not allowed, right? So make sure your fault proof functionality appear behind this button. Okay. So only one output universe is available. You are not going to allow users special multiple output universe. So we will change. You will change. Okay. You will change this tree view from 2 layer into 3 layers somehow. So try to make the universe group in either input universe or output universe. So I then use the select universe, right? So once you use the select universe, then the add fuzzy set button is enabled. If you use the select the input universe again, you need to hide these buttons. You need to think about the logic of the appearance of the user interface, make it full proof. Okay, I'll make it full. So in this way, so user click on a universe, then user can select primary fuzzy set, right? Primary fuzzy set. What kind of primary fuzzy set we have prepared? Triangular, Gaussian, sigmoid, left, right, trapezoid, pi, S, right step, left step. So these are the primary fuzzy set. User can select it. So user my special sigmoid fuzzy set, right? So right now user select universe 1. So add a fuzzy set. So as you can see, your tree view, right? Right now, you need to make it extend somehow into 3 layer, 3 label. Right. So and probably user, as you can see, this is the demo that I wrote. Probably 2 years ago. So a user can click on a line, a serious line, and then there's an actual point. I call it control point. So see this interactive user interface. It's pretty powerful, right? So user can somehow specify this sigmoid function by dragging on the line. It's much more intuitive. So user can move the center. As you can see, we are not just let the users change the center from the proper degree. All right, similar. But right now, user can easily free move this control point to change the parameter of this. Well, it take a lot of programming, okay? But actually, you can do that. Or otherwise, users can still specify the parameter right here. This is no problem. Okay, it's okay. So, and probably user might select this sigmoid, right? Sigmoid probably you change the name. Young. Okay, so the universe 1 into age. Try to build up okay, whoops. It's not consistent, all right? So probably you do not have this kind of problem. And I did not make it consistent, so it's okay. So young. And then so I will in this case because I specify you see I select a fuzzy set. So primary fuzzy set will be disabled. But right now I can add a so-called hit or modify concentration unity operator. Maybe I use what cut, no cut, that should be the value. Concentration so value. Add the fuzzy set. Alright, so it's a primary fuzzy set. Alright, it's very young. Okay, so it's very young. Again, I click on this guy. I can move. Oh, I cannot move it. Yeah, okay, I understood. It's value, so it's dependent on the young primary. If young primary somehow has shifted a little bit, well, as you can see, because the unity operator fuzzy depend on the primary fuzzy, it will change accordingly. It's fine. Okay, so very young. It's young. And how about output? So if I click on output, what it says, well, again, probably is well, I add another one, sigmoid, right? So this time I add probably Gaussian, no, not Gaussian. No, probably I add a bell. Where is the bell? No, I don't have a bell. Yep, I don't have a bell. Gaussian, this Gaussian. Okay. So trapezoid. I add a trapezoid. Alright, I did not import it yet. Okay. This is since it's a demo code. So what I have probably just triangle and the Gaussian. Alright, so this is a triangle. So I can move the control point to change the parameter too. And this is Gaussian, so kind of center, make a standard deviation a little bit. So in this time, user can specify probably this is center is middle edge. Alright, so this is middle edge. And how about the triangle? I'll move a little bit there. Triangle, I might call it old. And then user can specify a binary operator from these two, right? So click to assign the first fuzzy set. So I choose Gaussian, click. That's what you have done, right, in the previous assignment. And triangular, second one. So I'm not going to use intercept. Okay, intercept is all right. So it's young and the middle and young. All right, so middle and young. So I kind of use intersect operator to add a fuzzy set on the same universe. So I might call it young, no, not young, old, and middle. Somehow, user can feel free to use your fuzzy set, constructor, either add a primary fuzzy set or add a unity operator fuzzy set or use a binary fuzzy set on the universe they like. So right now, we have, we have a fuzzy set defined. User has a fuzzy set defined on the universe x1. How about x2? So if x2 probably income high or low or whatever, some error. And in this universe, user might specify probably a triangular fuzzy set and also a Gaussian fuzzy set. So once everything has been done, also in the upper universe probably have so does not matter. And I specify Gaussian fuzzy set and also triangular fuzzy set somehow too. So suppose the fuzzy set in creation or definition is complete. The next step should be what? Should be the fuzzyIfThenRule construction. All right, that is a new topic we will have in assignment 5. So here, so once a guy click on the if-then tool, so initially there is only rule ready, right? So how can a user create a new one? As you can see right now, we have 3 universes, right? X sub 1, X sub 2, and X sub 3. So X sub 3 is actually what? An output fuzzy set. But how about the input universe? Right now we have 2 input universe. So we intentionally like to make this user interface to let the user specify rule right here, and let the user specify condition and the inference. So that is the functionality we like to add in assignment 5. So we let the user construct if-then rule, and also we let the user specify condition, and then we provide the inference button for the user to get the result or this inference result on the specialized rule, right? So how can you use a specialized rule? Okay, let me show you again. If somehow user add another input universe. See, right now we have x1, x2. x3 should be the output universe. See, so if a user click on this universe, add a new universe. So that should be x sub 4. Your grid right here, you need to add another column x4, and also this another column x4, right? To let the users specify a rule complete, right? So because right now we have 3 antecedents, right? So if we, I don't think I don't know whether I can delete or not. Let me try that. If I hit delete key, okay, it's worked, all right? So user can feel free to add the universe or remove that universe, delete once it is clicked, and then hit delete key, the universe can be deleted. Probably you are not familiar with the delete key, that means event filing. It's okay, I mean you can stick on the default scenario that user can only add universe. But if a universe, if a user add a universe, you need to prepare a new column somehow here in the program. So we will learn how to use this control. This control called data review. So how can you use a special rule? You see, you prepare a button right here. Add a rule. Add a rule. So right. So rule is that in the universe x1, x2, x3, what kind of you should specify. So for example, if the rule 1 is that if it is very young, you select very young, click on this space. X1 is very young, and how about the x2? You need to use for proven, because right now each antecedent should be specified a fuzzy set. That fuzzy set should be defined on that universe, right? So if I select sigmoid right now, sigmoid fuzzy set is defined on the universe x1. Can I click this one? You need to have prompt that message for the user saying that, well, this is the column 2. It's usually designed for specify the antecedent or the fuzzy set on X universe 2, right? So you will not allow it. Otherwise, you will scroll everything. So suppose I select another fuzzy set defined on the universe X2, then I can click on this one. So once I click on that means I kind of define this rule. So rule is nothing but you need to specify the antecedents part and the conclusive part. Okay, that's it. And how about the output? So output is Gaussian 3 there. All right. So that is the interface we are going to build. So again, user create another rule. Well, never mind. Let the user specify the condition first. So how about the condition? Similarly, if the condition right now is very young, right? Very young. So very young. So if I specify middle age, I kind of change it a little bit. Maybe a little bit faster. So that should be Gaussian, right? Gaussian. So if condition is Gaussian, so I specify the Gaussian. Click on this one. Condition is Gaussian. Middle age. Is that the middle age right now? And how about the condition of this one? So what I have is a triangle, right? Triangle. And I kind of move this Gaussian a little bit to here. All right, this one. Okay, this one. So how about the condition x2? User can freely choose any fuzzy set right here. So since it's a Gaussian, it's a triangle, right? So I select Gaussian 2. Select the condition on this one. And then I select cut inferencing. So I can inference what? Inference this given condition. So right now our x1, my x1 is middle age, x2 is Gaussian. And the rule right now, which simply has one rule. X1 very young, X2 triangle 2, then the output is Gaussian 3. So output right here, output is Gaussian 3 right here. So user click on this inference. Well, results coming out. So that's the result. Okay, this is the result of the rule inference. We can see, actually we can try out. How about middle age and the very young? Middle age is right here. And very young is right here. So the intersection is right here, right? We just say that during the inference, you need to find the intersection first. And how about the mathematical? Mathematical problem is 0, 1, 0, 1. It is 0, 1. So the first integer we have 0, 1 firing strength. And how about the second the second antecedent? Gaussian 2, right? Gaussian 2 here is intersect with the triangle. Intersect with the triangle. So resulting intersected let's say it's right here. How about the mathematical degree? Mathematical degree is right here, so probably 0.68. And the first firing strength is 0.16, right? The second one is 0.68. So take the minimum one, so that should be 0.16. Use 0.16 to cut the Gaussian fuzzy set. So that is the result. And if I change it, let me change this. This output fuzzy set. See, turn out to be 1. So resulting should be accordingly changed too. And how about if I move the condition, the Gaussian condition, a little bit to the middle, to left? So right now the firing strength is a little bit higher. That should be the 4.2. So it should be 4.2, right? And then inferences again. See, the firing strength should be 0.42. One. All right, the whole thing about the inference is very simple. Each antecedent part get the intersection first, and then project to the output axis. That should be the firing strength of the first antecedent. And then similarly, we will get the firing strength of second antecedent. We take the minimum firing strength to fire, to cut. Right now it's cut. To cut the output fuzzy set. That's it. And if the user did not select the cut, that means the scale. Well, you click on it, the label keep changing. So right now we use the scale. If it is scale, the output fuzzy should be scale 1. So we like to provide this kind of interface. By default, it's a Mendelian fuzzy set model, right? Fuzzy in, fuzzy out. Anyway, so the output is just fuzzy out. Okay, that is the mission we like to have. And as you can see in the assignment 5, well, your form, you need to take advantage of each spaces of your screen. Just let the user easily, to enlarge or shrink certain kind of parts. So we need to use that. Okay, let me see if a defuzzification is asked. But this for the 3D display, we can only have 2 antecedents. So right now we have, it's okay. So right now our output fuzzy set is a 3-dimensional, right? So the 1 dimension should be the input universe x1. The second axis should be x2, and the output should be the inference result. So for this part, well, right now we just have one fuzzy-if-then-rule, right? So the result is a fuzzy set. But again, this is the result, right? So if we use crisp input, that means the system will use your resolution to try to build up input value, right? On the x1 axis and also on the x2 axis. So we will have a pair of x1 and x2 ready, and then inference the output result. So output result should be a fuzzy set, and then we like to report the COA to the user. So each x1, x2 will receive a COA that should be the Z value out, and then we plot, we explore all the possibility of input combination, and then generate the output response surface. Sorry, all right. So resolution 30 means that for x1 we use this resolution to generate 30 value, and also x sub 2 30 value. So combinatorially there should be a 900 inferences instance. So if you click on this guy, you will get an output response coming out. So similar, this kind of example has been especially in the textbook. So you need to use your system to verify the resulting surface is the same as that appear in the textbook later on. You can try build the fuzzy inference system as the example shown in the textbook, and check the output surface whether they and the service is consistent with the output in the text box or not. OK， 好，所以这是我们最后要阐释的一个 fuzzy inference system。User can special mandate 最典型的，然后 set up 这个 rule， 然后呢，因为它是 2-dimension 的input universe， 所以我们可以 show 它的 output response 在那个 2D 的那个 3D 的一个 graph 上头啊。Alright, so if your input is just one-dimensional, okay, so let me remove this S2 universe. So everything turned out to be a one-dimensional antecedent, right? So right now we still have a rule specified. So it is very young. Output is extra substrate. It's young. But in this case, input-output just remain to be two-dimensional. One is the universe, input universe. The other should be the output universe, right? So again, similar, we still can inference that, but in this case, there's no change. That should be 1.5 because it's a symmetric output. Because what? Because output is symmetric. Symmetric, so it's a Gaussian cut, right? Gaussian scale. All right, well, if it's still cut, still again, output inference still remain because center does not change. Center right here. Probably around 1.7, 1.5, 1.5 or 1.6 right here. So no matter where is the resulting cut, the COA, because COA is the same, because output fuzzy is symmetry. All right, so properties, if I change the output fuzzy into triangular, try to make it a little bit different. And then I kind of change the output fuzzy is not Gaussian, right? I highlight this guy, well, no, output select triangular, change it, triangular. Okay, and then I inference. And CRISPR value should be a little bit changed. Output 的方式是这一块，那它 centroid 会 change， a little bit change。BOA 可能 change 更多哈，BOA change 更频繁。Right, that's the functionality we like to have in our final assignment 6. Okay, right. So let us read about assignment 6, 5 instruction. Enhance your assignment again. Assignment 4 turned out to be a new assignment 05. This is a trick you did in the last assignment. And then add a parameter change the event. Okay, we have done that, assignment 4 to your universe class, right? But today we like to have is that we try to enhance our unity operator and binary operator file set, and by preparing an overloaded operator. We kind of try to use exclamation symbol to stand for a non-operator on the fuzzy set. And as you see in the quiz 2, we do mention that we like to use the symbol. We like to use the operator symbol to represent an intersection, union, and cut operation and scale operation, such kind of thing. And remember that all these operator, this symbol in C# programming language can be overloaded for your new type. Can overload this. What is overloaded mean? That means you still use this symbol to deal with your class, your object in different meaning. Anyway, you can just reuse this symbol for your class. That is the purpose of our assignment. Okay, so rewrite your application or adding unity and binary operator fuzzy set using the newly added operator. Add a virtual property. Okay, we need to add we need a new property called maximum degree on the fuzzy set, right? On the fuzzy set. So add a class of fuzzy. Okay, we will create a new class called fuzzyIfThenRule. Right? Think about the data structure required in this rule class. So basically, we will have a list. A list of what? A list of antecedent fuzzy set, right? And also we will have a fuzzy set, output fuzzy set specified within the rule. And since the rule has been designed as a class, so the if-then-rule class should have its own functionality, try to inference. So once a user gives a condition, then the if-then-rule object will inference the final result back to the user. So investigate the data structure required for a fuzzy if-then-rule to define its data field and property. or probably some event should be special too. For example, the antecedent part can be a list of fuzzy sets on different universes. So make sure you need to check that. These fuzzy sets are defined respectively on different universes and their conclusion parts. And in this class, design require public method for coder. For current purposes, for example, user might like to inference. So user will provide a list of fuzzy sets, that means the condition. And then the if-then-rule will return the result inference, the inference's result. So normally for a Mandani system, the result should be the fuzzy set, returned it to the coder. Alright, so when condition is a given list of condition fuzzy set, well, so similarly, the user need to provide a list of fuzzy set. So for proof mechanism should be adapted. You need to check whether the supplied fuzzy set are separately defined on their own universe. Okay, so prepare a UI for the user to create and show fuzzy if-then-rule. So this time we will use a new control, so-called data grid view. Okay, so multiply fuzzy set class to have, okay, this is very important. You need to modify, because right now we try to inference our rule, right? But by default, right now, once a fuzzy set is created, then the point will be instantiated. So that means if you create a fuzzy set, then the point will be generated. And since your memory is limited, if you keep create point for any fuzzy set, then you will run out of memory. Why? As you can see, because of, for example, in our previous demo, we kind of use the solution 30 by 30, right? So actually that will came out 900 instance. And if instant will be supplied to inference the result, right? But during the inference, there's intersection and also a lot of intermediate fuzzy set will be generated. And if those intermediate fuzzy set has point generated, then it will use up your memory. So we need to change a little bit about our fuzzy set instantiation. By default, we will not initialize the point. Only those fuzzy sets needed to see, we needed to check the shape. We instantiate the point. So we need to do this kind of modification. Otherwise, you will see your application stop because it run out of memory. Right. So that is the mission of our assignment 5. So let us go back to our assignment 4. Try to upgrade into assignment 5 in the first step. So here again, I use a newly created project from one of your students. This is again the chain, right? So that is assignment 4, and I think she has completed all the requirements somehow. And then let me see the result. Okay, oops, not 3. So if you copy from assignment 3 to new assignment 4, see in the debug. In the debug subfolder, you still have the old 03 SQL file. So that's the students have new variables, right? Variables. So let me try it. So change it into H, G, H. Okay, H, fine. And on H, right now, tribute right here. On H, we kind of create sigmoid. Sigmoid, so I said, new one. Sigmoid. Parameter right here. Slope, probably -2. Oops, right? I cannot specify -2. It's not reasonable. Slope is not, it's just, we cannot make slope with 0, right? So, well, can I do it? All right. 2. .5. Right. So I should change it. That should be the O, not the. Okay. So this was set property. That should be O. And then the center. Move to the surface somehow. Okay, it's O. And if I select O, select the constant unity operator on this unity. Where is it? Okay, right here. Value. Okay, by the way, it's value. So a new unity operator for this. Okay, value O. So I will change it into value O. Since it's a title, so I can use remember so it's value O. Right, so it seems everything is okay. So up to this point. All right, okay. So right now, user can specify age. All right, so everything is okay. Okay. So I try to convert this assignment 4 into assignment 5. So the first thing is that try to able to change the folder name to 5, right? First, and then I need to change the solution file name too into a 5. And I also like to make sure this project name change into 5. And also within this project, I like to change the project name. Project name into 5, right? Okay, seems okay. But the problem is that solution needed to, because right now the path has been changed, so I need to change the content. Content-wise, you can probably add a text file. Click on text file, and then drag this solution file into a text editor. Oops, not here. Here. Okay, so that's the content of solution file. So basically what I need is find 04. Oops. Not this one, not this one. Okay, right here. So right now I change the project name into 05 and the path. So 05 again. And CS project should be 5 again. So solution, many different files. That's why we need to change, because right now the path has been changed to 05. Project name has also changed to 05. So make sure they are consistent. And another one, no, it's not. So it's complete right now. So the modification on the solution is complete. Should I do anything change about the project? Yeah, actually you can do that. But so far we can let the Visual Studio change that for us. So up to this point, I have a solution, new solution called solution. So I can click on that. So basically, Visual Studio just open the .stl file. Try to see whether the path existing and the project file exists. Then you will pop out everything's okay. So far, you see, you should be very proud of yourself, because right now you kind of create a project. You create another CSS file, right? It's kind of exciting, right? So you kind of catch up the algorithm technology to some distance, to some extent anyway. All right, so the problem is that right now it's a project. See, if you click on this project and then right click, it's okay, because we try to change the property, some property of this project. Or otherwise select this one, or you can select the project, the menu project. Also pop out the project. So by default, because we just copy from the previous project, right? The assembly name, the executable name is buried in the old one, so I needed to update it to change to 5. And also, the default namespace upgraded into 5. I think that's it. And save everything. But go back to the source code. source code right here. Anyone will be okay. Because the source code initially is created from the project 4, so right now project 4, but this time I kind of change the space name with the help of Visual Studio. All right, with the help of Studio, and then I need to change it up into 5. So let the Visual Studio change it all these instances for us. All right, so far we have completely convert assignment 4 into assignment 5. So we compile it again. Try to make sure everything is okay. Okay, similarly, this is okay. Yeah. But again, you need to change the title somehow. So let us make sure it do upgrade it into assignment 5. So double click at this and bin debug, right? That's the original SQL file 04. So we can remove this 04 to make the source code or make SQL code much more neat without mingle with the original 04 stuff. Okay. All right. So about the time, we kind of extend our assignment somehow. All right here. Okay. So far it's okay. So let us study the new control a little bit. So if you like to follow me, we kind of add another project. Just try to get us some exercise, some new control anyway. So I will show you right here in this new project. So desktop, C# desktop, WinForm. All right, just WinForm application 2 is okay because we add a project to this solution, so it's okay. We don't need a special location. We just use this project to learn some trick in using new control or explore the functionality or other control anyway. All right, so this is the assignment WinForm. So if you are creating a very complex application, for example, Visual Studio is an application, right? Usually, in powerful or large application, we should have a menu, right? You see, this is the menu, and also we have a so-called button list, and also we have a bar behind the screen called street. So similarly, in Visual Studio, you can add this kind of user interface. For example, if we drag a menu strip, drag into it. And within this menu strip, you can try that. You can type something file, usually file, use the edit, 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 right? And this is submenu coming here, file. So usually we have open. And by convention, if you put a 3 dot there, that means the dialog will pop up for you. And then at the end, probably you have exit, EXIT somehow. Right? So you can try that, feel free to try it. And also, in addition to the menu, there is a called toolbar, tool strip. Tool strip, you can add a button by default. Not just button, you can actually add several things right here. Again, button 2. So menu strip, tool strip, and also have a status strip behind. So by the way, you can see right now these 3 bars, they are object, right? But by default, they have been stuck to the top, stuck to the bottom separately. See? So this is status bar. And in status bar, you can add another kind of control. Usually we will put a label there. And sometimes you like to probably have a so-called process bar. Feel free to try it. And in the middle of the application screen, we will add what? Usually, in my convention, I like to add a so-called split container. by default, it has been dark to the center, right? So you can check the, so right now, the form is apparent there for these 3 bars and this so-called split container. See, dark, right here, you see, dark is fill. How about this manuscript? The dark property has been automatically set to the top. See, top, right here. How about this toolbar? Also top. Yeah. How about the status bar? Bottom. It's kind of convention. If you have something wrong, you just click on this, you just select these controls. Whoops. Excuse me. Probably Windows pen. I chose the pen. Okay, so you can select it from here. Split container 1. Because by default it's dark, right? So if you use special none, then you can resize it. So in order to make them distinguish, I like to add a so-called back color to let you know the differences between this panel, back color right here. So this one. So remember that there are 2 panels hierarchically dark within this split container 1. Panel 1, panel 2. If you like to access it, you need to use the name so-called split container 1 dot panel 1. This guy is dot panel 1. So panel 1 is another panel, right? Another container right here. So let me show eventually what we like to have. What we like to have right here. Okay. Let's see. It's a demo application. Oh, well, as you can see. So closely take a look at the split container usage right here. You see, kind of separatable right here between these 2 ones. And then within the right-hand side, right panel, we also tail it, change it. So you can feel free to use split container to arrange your screen somehow. Listen, by hierarchically, you specify that. So, for example, right here, I will add another split container within the right-hand side, within the panel 2. And this time, I set the back color into another one to let you see the differences. In the split container, by default, there are 2 panels, right? But by default, they should be vertically separated. But again, if you click on this split container 2, there is a property called orientation, I guess. Orientation vertically. So if you change it into horizontal, then it's horizontal. Maybe you would like to have similar kind of layout right here. So we are up in second, right? Up in second. But also there is some space there. Let me check it to see it. Alright, so probably this is a panel in the left hand side. Okay. So we add another panel 2 right here. Excuse me, split container into this place. Change the color to see the differences. Again, the orientation. Well, you can feel free to design your own interface, okay? To design your own layout somehow, right? Right now I try to achieve the similar layout as you can see in the demo page right here. We have a panel up there. Okay, so right here we can directly add another panel. And again, I specify the color, background color properly great. Right, so right now you need to pay attention to the parent and child relationship between two controls. So it's a container, right? It's a child, and I can specify dark. Oops, excuse me. Dark with respect to its parent. Dark is with respect to its parent, top, there. And then I drag another split container. By default, it will dock. It will fill anyway. It will fill the rest of the space. So change the background color too. Okay, I think we're almost done with the similar layout, right? Similar layout. Okay, probably green. Attribute right here. Well, it's almost down there. Okay. How about this place? Well, we have so-called tab control. And actually, we have 3 tab control. So drag and tab control. By default, it is not dock, but I like to make sure it will dock to its parent. So similarly, especially dock all the place. And I believe we should have 3 pages, right? So how can you spell it? Actually, click on this tab control. There is a collection called pages. Well, tab pages, right here. Add another pages. We have 3 pages. And finally, I think we have what? This is the rule, right? The first page. It's okay. Let me just go. Second page, if then rule. We have if it is scanner have this box. If then rule. Okay. For assignment 5, we already use a special if then rule. And again, as you can see, there's another split container there, right? The first part of it, let it use a special rule. And the real part of it, let it use special condition. Okay, so in the second pages, we add another split container. Change the big color for you. To figure out the hierarchy. Okay, about orientation. Orientation still horizontal. And finally, once everything has been laid out, see, it's right now it's not docketed at all, right? So final step, I kind of set its dock property into fill. Perfect. Right. So fill up the space of this window. So that is the interface we like to have. So we will have a menu bar, toolbar, status bar, split container. Everything is right there. So click on that. No, that's right. Because we have 2 projects, right? So by default, it should be the first project. And right now, I have a new project right here. So let's select as starting project. So you need to try somehow. I mean, if you are interested in using any kind of user interface, you can do that. So that can be changed, right? How about, well, we cannot see it. Tab, well, I cannot see it. I changed a little bit about the back color of this panel. And also, the back color especially is a panel, right? It's a panel. Okay. Right. Okay. Okay. But since right now a lot of user interface has been special on the phone, so it is better that specify when the phone is about to show up start position. You know, the Windows state is maximized by default. When you execute the application, the user is take up all the space. So that's what we have. So see, there's a separator bar right here. So user can click on it. User can separate it. Then our page 2 can move it. Okay, feel free to try it, but you should have idea that it is hierarchically displayed somehow. Some control is special within a parent control. Right? So all the panel and the speed container, they are panel anyway. They are panel grouped together, and then once you insert a speed container within another panel, then the parent hierarchy will be very deep anyway. But it's okay because we kind of let the user specify the size. Depending on the Windows size. Okay. Okay, I'm not going to stop. So we will not have break. If you need to go to the bathroom, you feel free to take a break and then come back. Okay, so I will keep going on talking about the a new control we are going to have. All right. So I think similarly we will have what public grid showed up right here, right? Public grid. So how can we say that public grid? Should I use? I had better use the original one. Okay. So I kind of switch back to the students' work. Okay. Come to. Main phone right here. It's pretty crowded somehow, amazing for the students, but we're going to cover this. So once you have your window, separated by the panel, you need to figure out and think about, well, within this panel, this subpanel, which control should be the most important one? If it is the most important one, then usually within this panel, we kind of anchor. We will anchor its boundaries with the parent. So once parent is enlarged, we can take advantage of the space we have. So that should be anchor property. Not just top, okay, it's okay, right. So it's all right. And so right now, I think, why everything's, I don't know why that is. So that's kind of messy somehow. All right, I don't have a space. The speed container wise, you need to arrange it by yourself. Okay, right now I'm not going to modify any layout. I'm going to show you just how to use a so-called property grid. So you drag a property grid, data grid view. That should be data grid view, So data grid view here. And since it's very complicated, it's a complicated control. So we have a user editor right here. So if we click on this editor, it will pop up. Well, we can add a column, or edit the column, add column. And by default, we will enable edit. All these options can be specified within the property grid. Anyway, you can select this control and then change the property accordingly on the property page somehow. But the idea is that once user create a new universe, we need to add a column. So suppose right now, so we need to programmally, we are not going to, in design phase, it's just set up a fixed where probably 4 column. We will let the user dynamically add a column to this data grid view in order to let the user special rule, right? So this, okay, let me change the name. Data grid view, DGV, that should be rules, right? Rules. There's a rule. And if you take a look at the property it has, you see, check the collection. There's a collection right here, columns, right? So it's a collection. I think that is the way the columns. Row-wise, row is not allowed to set it initially, so there's no only row available. Okay, columns. So once you use create a new universe, okay, let us go back to the event handling function here, button universe create. So we know once the universe create, okay, it will be added to the tree node, right? Tree node is so far is okay. Then we will add a column to rule and condition data grid view. Okay, I did not show. You need to do that by yourself. Okay, what I'm going to do, I just try to use this rule grid to show you. You will have another data grid view, right, for the user to specify the condition. So condition is similar to the rule. The only difference is that we will not have a conclusive column in the condition. So actually, you will have two data grid view. The first one is called data grid view 1. The second one should be DGV condition. We already use a select fuzzy set to serve as the condition, right? So similarly, the operation should be similar. So let us go back to this code. So we need to add a column to rules and the condition data grid view. So how can you add it? Similarly, we will DGV, right? Condition, no, rule. The condition part, you need to do it by yourself. What I'm going to demonstrate will show you just rule. Columns, right? Columns should be capitalized. Okay, columns. It's a collection. It's a collection of what? Of data grid view column. So there is a class called data grid view column. If it is a collection, definitely there should be add a function for you. So how can we add it? Well, you kind of prepare data grid view column, put it as an argument, then you would add it. So otherwise, you just special a name and the column name and header text. Well, in this time probably because we just what? Columns. So just columns. Probably that will be enough. So how about the columns? Column name. And we can directly use the universe name, right? Universe name, title, tag right here. Universe name. Do we have a name? Title. Well, never mind, because we have this guy, chart areas. Universe. New universe right here. Target universe. So add target universe. We have a title, right? We already use the title. And how about the header text? Well, it's the same. Tag universe title. That's it. But again, if a user changes the title name, you need to change it back. So another way is that you kind of new. Let me show another way. Okay, this is another way. Data grid, DATA grid view. Data grid view column. No. Data grid view button column. Okay, data grid view column is an abstract class. Actually, you cannot instantiate any one of them. But we say data grid view text column, text box cell. No, text box. No text box, text box. Okay, text box column. Column. a column, new, we need to new it. A column title somehow. Header text. Anything. Okay, you still can use that, but I don't think we need to do that. Either way, you kind of prepare a column and then data grid view add that column. But right now we do not bother about the column at all because column is just what we need just show up the name. So you need to make sure once the universe name, once the universe title changes, then the header, this column, you need to access it. How can you access? Well, probably you know this is the zeros, zeros universe, then that should be zeros column somehow. Okay, you need to make sure that the interface base text to consistent with the column name anyway. So we don't need to do this one. Anyway, column just added. So up to this point, we kind of prepare the structure of data grid view only. So once I use a special universe, so see, once I create a new universe, a new column has been prepared, right? Similar like that. Okay, but for the things right now, you need to change your data tree view. See, we need to have another layer. I mean, the first layer should be just a category. Input universe, output universe, because right now we need to use a special like that. Well, this what it said should be input universe. The resulting for this should be special on the output universe. They should be distinguished anyway. So you need to change a little bit about the tree view to add two. Well, let me show you somehow. Okay. So universe 2. But as you can see, once a guy add a new column, a row has been come out. Because by default, data grid view has been prepared a temporary, so-called buffer space for the user to type something there, But that's not the intention we have. We'd like to provide a button. Once the user click a button, we add a row programmably. So in this time, you need to go back to the data grid view and turn off an option that should be auto property or this data grid view. Allow user to add row. Make sure this turn out to be true. Let me try that again to see if it will work or not. So the universe, you see, as you can see, universe 1, universe 2. So there is no any buffer line, buffer row came out. We will programmably add a row once the user click a button. Okay. And how about the first column? This is the called column header. Should I use it? Let me check it. Let me see it. Oh no, I close it somehow. So once you use click this guy, add a universe, IfThenRule. Okay, just let it remain there. That's all right. All right. So far, we kind of use data grid view and add a column. Once you use the click universe, see like that, and then once you use the click this button, add a rule. Then the rule will be generated. So I will show you how to generate a rule for that. So we have bot. Oops, excuse me, it is still running. So I terminate it first. Drag a button, and the name should be add a rule. ETN add a rule. Subscribe as quick event. All right. So how can we add a rule? DGV, right? Rules. Okay. And rows, add, for constructor, So you can prepare a data grid view rule. And here, add a number so row automatically anyway right here. And also you can prepare, if you know the contents of the row, you can invoke this constructor. But right now we simply just add. Need to get it the add. Well, let me try that. I probably just add will be now. I don't know. Make sure for that. There you go. So use the create a universe, second universe, add a row, add another row. Okay, it's kind of working, all right? Somehow in this way. All right, so you need to do that by yourself, okay? For the conditional data grid view, this is conditional data grid view, so you need to do that for you. And right now it's about the time we shape a little bit about our tree view. Okay, so how about the button name? No, not here. It's not button one. Let's call add a rule. And then you can put a button, delete a row. It's very simple. Just okay. Delete a row. So how can you do that? So DGV. Everything has been put in DGV. Selected row. I think there is a row. Selected rows. Well, you can multiple select rows. So that is again, that's a collection of what? Of data grid view selected row collection. Interesting. That should be rows remove. Remove data grid view. So data grid view rows. DGV rules. Selected row. Is there a selected row? Selected rows. Okay. So no way, you need to know the data type. Data type should be data grid view. Data grid view row. That is the item. Okay. R in DGV. This I do not have a chance to introduce you a whole statement or C#. It's new. I mean, you cannot find it in C# or C++. But we call it for each. Right? This kind of format is kind of new to a guy who did not use C# before. But its idea is that, well, since the last part is in the collection or a list of an object. And each object, I will loop through each object, which means I will loop through each object of this collection one by one. And each instance, we need to know the data type. So we know selected rows is a collection of data grid view row. So each element, the data type should be the data grid view. So you can specify a local name, I mean an element's name. So that means once computer executes this statement, it will loop through each element of this collection set, and each one will be regarded as R. So in this case, you can simply invoke this constraint, this statement. Data grid views the rows, remove R one by one. So that will do anyway in this case. So let's try it a little bit about adding a column and adding a row. So add a column is that you can add a universe, right? Add a rule, add a rule, add a rule, add a rule. So now we have 4 rules specified. And once I highlight this line, That means selected row. This is selected row. If I select two rows, oops, no way. This should be one. Control. If I hit Control, yeah, two rows had been selected, right? I had better type something. 1, 1, 2, 3, 4. Okay, so it's clear. And if you use the select 1, hit Control, select 3, so two rows has been selected, and then I kind of delete rows. Alright, so it worked anyway. So data grid view is simple. I'm using the add structure of the columns and then add a rule. But right now we like to do what? Since it's a rule, right? This called antecedent part and then the conclusion part. So we need to separate the input and output there. So you need to change your tree view. Tree view is right here, right? Yeah, tree view main right here. So by default, your tree view has a default label. The first default label specified. So node selection right here. You will add. The first one should be called what? Input universe. The second group is called what? Output. So the first label, the node or first label, simply serve as the classification. Okay. So in this case, user need to select either it's the input or output universe, and then the universe will be defined within the subnode for that guy. Okay, so you need to do that by yourself. But so currently, I mean, if these students, in this case, what will happen? If I select this guy, and then that should be the, it is allowable to specify a new universe, right? And that should be defined within this, the first level. You need to figure it out by yourself, okay? I'm not going to spend time to do that for you. You need to make them hierarchically displayed within the child node of the input universe. If it is input universe, if a guy select this input universe, you need to move this to this place anyway. Okay. So input universe, but I need to do that. Well, I'm not going to make it correct anyway. So right now, suppose universe is right there, another universe right there, and then once I click on this universe. User can specify the fuzzy set, right? So fuzzy set is okay right here. Keep on specifying the second fuzzy set, universe 2, fuzzy set 2. And then about the time within the user. So suppose user create a new rule. So for the universe 1 right here, right? If a guy select the fuzzy set and then click on this cell, we will recall the reference of this fuzzy set into this place. That is the purpose we're going to achieve. Okay, so that means the event should happen. We should subscribe the cell quick event, and then check the fuzzy set which one is selected, and then put it into this cell. Okay, so how about the fuzzy set? We always keep a selected fuzzy set in the so-called target fuzzy set, right? So target fuzzy set is a target. We like to add it to the grid. So we came to the data grid view, then we subscribe what? We will subscribe its cell quick event. Cell quick event. Cell content quick. Cannot remember exactly the difference. 内容 content, any place. Okay, so probably a cell can contain multiple instances anyway. So if a specific content is clicked, then they will fire this event. Otherwise, you simply click on cell. Also, we can subscribe this one cell quick event. Cell quick event. Double click it. The important information of this event firing will be stored on the argument. So you can explore what kind of information has been carried to this event handler function E dot. All right, as you can see, the column index, row index. So you know the column index and row index. When you need to probably just column index, somehow column index, you need to make sure, well, the problem is that, never mind, we just, and the sale, okay, I think that, let me think, E dot, column index, row index first, row index, and then E column index, right? So we have two index. And how about the data review, DGV rules, right? We have a probably called cell, I think, no? All right, so it's kind of hierarchical store in the row. So I need to access rows first. Rows, get the row index first. So get a whole bunch of rows, right? So we have rows, eta row index. And then we kind of access. Nothing happened, all right? So it's still not correct. Let me find it out. DGB rules, that rows. Oh, excuse me. That should be the indexer, not a function call. You need to use the indexer. Indexer is just an ID, so that should be rows ID, rows index. All right. So I get this row, get a row currently. I mean, click on the cell, and then I try to access its cells. E dot column index. So right now I get what? I get a cell. And the cell has a tag. Okay, beautiful, there, right? So right now I identify the quick cell, and each cell has a tag associated with it. So tag, I will store the target fuzzy set into this cell. The idea is the same, right? A user interface, if a user interface has a tag property specified, then I can use this tag to store the associated object reference. Right, so that is the idea. And then how about the text? It's a tag, right? How about the text or the cell? Not the cell. Okay, so title, no. Okay, value. Okay, should be value. Yeah, it's a value. Value is an object. It's fine, I think. Do we have okay, value. Okay, so the target. Because we have stored the object reference, the fuzzy object in the tag, so it should be okay. It simply show the face, right? So the target value is title. It will be okay. Yeah. But again, the code that I implement here, I do not check the legality, because if user select fuzzy set in the wrong column, in the wrong universe, then it is not should not be allowed. So user right now create a universe, second universe, third universe. Select. Suppose this is the input universe, right? Add a fuzzy set, triangle fuzzy set, another fuzzy set, Gaussian fuzzy set, and then the universe 2 should be another input universe fail. Left, right. Okay, so suppose universe 1 is this is the input antecedent part, and the universe 3 is the output universe. Alright, so you need to do that by yourself. You need to put the universe 1, universe 2 under input universe category, and then put the universe 3. Okay, let me spell universe 2. So suppose the output is Gaussian fuzzy set. Alright, so another one fail. And for universe 1, I have a condition, triangular. No, not triangular. Triangular 2. It's okay. And it's another triangular. Okay, I'm preparing the condition that I will special two rule. The rule one should be the antecedent universe one, fs1, left right fs1, then output is fs2. The second rule should be second one, second fuzzy set, second fuzzy set, second fuzzy set. And the last two should be used for the conditioning anyway. Right. So in this case, user start from here, specify where I have a if-then rule. How about universe one? So user click on this guy, right? Triangle first one, and then click this space. It's legal, right? This is universe one, so this fuzzy set has been specified in universe one, so it's okay. But if user special a fuzzy set defined on the universe two, and if you click on this guy, you will not allow this to happen. Okay? You need to do the full proof because it's illegal, it's meaningless at all. Alright, so in this case, user click on triangular fuzzy set one, click on this cell, okay, triangular fuzzy set one, and user select fail fs1 on the universe 2, click on this cell, it's legal, so I allow the user specify. And how about output fuzzy set? Output fuzzy set right here, select Gaussian, click on this guy, it's okay, complete. And if you add another rule, okay, similarly, Gaussian 2, click it on this screen, left right, click on this cell, fail, click on this cell, it's okay. And how about a condition? User can only specify one condition, right? Can specify only one condition. So in this part, once user create universe, you need to do similar operation, right? But just one rule. The user can select condition property, triangular fs2, triangular fs3, and then a rule is complete. Okay, so this is the interface we are going to have, and probably the last interface we need to add is another button right here. Inference. We just add a button. Inference. Oops, made a mistake. Okay, if it is a mistake, so you just go to the reference and move to the references, delete. Or probably come back here and then remove. 重设就好了哈 remove. So property text is inference. And button name. ATN. Okay, so once the user click this inference, then there should be a resulting fuzzy set generated, and then also plot on the the Microsoft chart. That is the purpose we have. So I think the user interface up to this point is complete. So right now we need to write our new class, right? Okay, so go back to our project. We will add class. So the suggested name is that should be if then rule. Well, actually it's a fuzzy rule anyway. So if then fuzzy rule. To think about the data structure required for this if-then rule. If a user like to create if-then rule, right, then definitely the user need to supply us some data. And those data required for this if-then is what we will use, because we don't know the dimension, so we cannot use the fixed array for the antecedent part. So the easiest way is that we use a powerful class provided in the dynamic we call it a list. And this temporary class, that means you just can supply the elements data type. Suppose the data type is a fuzzy set, fuzzy set. antecedent. Anyway, it's antecedent. So since it's a class, it's an object or list class, so you can directly new it in your member definition or this class. We can directly initialize. So we have an antecedent. Basically, antecedent is a list. A list is actually similar to a collection. So you can always use add such kind of thing to increase the content. And also we have what? We have fuzzy set. For each rule, we have fuzzy set. Conclusion, C-O-N-C-L-E-U. Let's see, conclusive, antecedent, conclusion. Okay, actually that's a conclusive fuzzy set. But since we have antecedent parts, it's okay. It's antecedent and conclusion. Antecedent is a list. Conclusion is an instance of fuzzy set. So, user needed to prepare this step for me, complete. Otherwise, I will not create an object or the if-then-rule. So, our constructor setting CTOR. Okay, hit the tab key twice. Then you ask for it. You should give me a list. Fuzzy set. You should give me a fuzzy set. Conclusion. We directly copy the reference only, antecedent. But you need to check somehow. Otherwise, if a user give you rubbish data, I mean, for example, two fuzzy sets defined on the same units, that is illegal, right? You need to check that somehow. I mean, you need to do that by yourself. Conclusion. Right? It's very simple. For the mission or if-then-rule is what? If a user give you condition, you need to what? Inference, right? So you need to provide useful public function, inference. Once the user give you what? A list of fuzzy set serve as the condition. You need to send the result back to the caller. That is the mission or if-then fuzzy set. What kind of data will be sent back? Well, by default, we think that if-then rule, this fuzzy rule, is a mundane fuzzy set model, right? Fuzzy in, fuzzy out. So I'll return a fuzzy set back to you. That is a promise, right? The inference will return a fuzzy set back to you. So in this time, your fuzzy set output initialization with none, and then return output. Okay, but you need to think because we have finished all the reading. I mean, all the stuff in the on the fuzzy inference system. So you know, if it is a scanner model, output is not a fuzzy set. So if you want to inherit, I mean, you want to exercise object-oriented technology for the scanner if-then-rule, you need to prepare a derived class inherit from this one. But the fuzzy set will be duplicated anyway somehow. Or probably you would like to make this if-then fuzzy rule is a general rule. So beneath this class, you have if-then mundane fuzzy rule, if-then scanner rule, if-then Komodo rule. Up to you. You can redesign this class memory by yourself anyway. But right now we simply focus on that. Supposedly, this if-then rule is used for mundane system, mundane fuzzy set system, fuzzy in, fuzzy out, somehow like this one. Okay, but for the inference, sometimes user might give you what? Give you a list of real value, crisp value, right? So the inference or this function will be we call it overloaded. Not list of fuzzy set, a list of double. So run-out condition is a list of double. You need to do that for you. just like the exercise, the test problem we have today. Okay, it's kind of two kind of inference, right? Okay, so far it's all right. So we kind of take a range of object-oriented programming technology to extend the functionality we like to have. All right, so we go back to the fuzzy set. And during the inference, what kind of symbol we like to have? Well, we like to have intersection, right? Intersection. And also we like to have add a probably called mathematical degree. We need to have this guy. And also we like to have a union, binary operator, right? And what kind of thing we like to have? That's it. I think that's it. Give me what we do have. So okay, so let us prepare. So it's a new start right now. We try to define overloaded operator of C# for our fuzzy set. Okay, that's the purpose. We try to define. So right now we define this, we overloaded this operator right within this fuzzy set class. And usually, let me try it. Usually you need to make sure they should be public. And for example, we like to define what? Define intersection. Intersection, we kind of use what? And, right? Using operate n% to. So, for this operator, what kind of stuff will be returned? Union, right? Excuse me, intersection, right? So we will guarantee return what? Binary operated fuzzy set. Okay, we'll return a binary operated fuzzy set back to you. It's promising. It's a promise. Operator, it's keyword. You cannot change this keyword. And then after the operator, you need to supply the symbol, the operator symbol. So we try to override this operator. The symbol is n%. Okay. And by default, n% is a binary operator. I mean, it's in C# programming language. So you need to supply two arguments for this overloaded function. So fuzzy set F1, easier. Fuzzy set F2. Let me see if there's any problem. So we guarantee a binary operator fuzzy set output. Return output. Do I need to have space? No. Oh, okay. Those function is not belong to an object. So again, not just public. I need to special another module static. So we don't need to instantiate an object at all. We can just use this operator to directly. I mean, it's the parameter you can either way have space or no space is okay. So kind of define. Well, if you give me F1 and F2, and then between this F1 and F2 you have a symbol, have operator and, then it will invoke this. This operator, this operator function. So, because we overloaded operator n, right? So we need to have what? Binary operator. Binary operator ready. Binary fuzzy set operator, right? So OP, what kind of operator we need to name? New intersect. I don't know what kind of class name. Let me check. Okay, what is the class name? Intersect. Okay, here intersection operator. New intersection operator. Okay, this class is defined by these students. Okay, by this thing. Okay, so we have operator already, right? So output is what? Output is new binary operator fuzzy set, right? How about fs1? Oh, okay, f1. How about fs2? Oh, f2. How about operator? OP. And this will return output. But probably, let me see. You don't like to. Okay, let me show you. But probably it's just return new binary operator fuzzy set f1, f2, new intersection operator with one line. Logically, they are exactly the same. Okay, they're exactly the same, right? This operator is overloaded to deal with the fuzzy set intersection operator, right? So it's very simple. It's just one line. If I have two, well, I said if it's not. So how do we use it? How do we use it? Operator N. So let us go back to your user interface. Remember that the user can right here, new binary operated fuzzy set, right? Within this code. So see, how can we do that? Usually we just here we have OP new intersection operator, right? Come out here, and then at the end we kind of created the fuzzy set equal one new binary operator fuzzy set. So see F1, F1, OP right here. So in this case, because right now we have just operator ready, right? OP is now okay. We don't like to explicitly invoke AP. Okay, so this is intersection. So we don't need to use OP again. I kind of comment this line out and then make it a declaration. Move it to this place. So since 0 is intersection, right? Is an A intersect B. So I simply say that created a fuzzy set equal what? Selected fuzzy set 1. Selected fuzzy set 1. And selected fuzzy set 2. Okay, that is the function overloaded. We kind of use this n% to represent the intersection binary operator. So see, created fuzzy set equal what? Equal selected fuzzy set and selected fuzzy set and mean the intersection. So created fuzzy set is ready there. The air chemistry is that because we did not initialize, so I put a non-initialization there. So make it the so it turned out to be that we did not manually invoke any constructor. We simply use this operator fuzzy set to represent this operation for us. So it's the n% there. We can try it. We set breakpoint here. Okay. So let me run the work of these students line by line for you. So see, we create a universe. Then on this same universe, we have a fuzzy set, another fuzzy set, Gaussian fuzzy set. Already there? Okay, fine. And then we select what? New binary operator, right? So we need to specify where? Here. Triangular fuzzy set 1, click on this place. Gaussian fuzzy set 1, click on this place. So we use this function to specify a binary operator for this intersection. Intersection, right? Intersection. So the zeros. Click on this button. So we came to this line. So we know that we have a file set ready there. It's a triangular file set. How about second one? It's a Gaussian file set. So right now we are about to invoke this statement. This statement is a binary operation, right? And the ampersand has been overloaded by our code. So if I hit F11 key, oops, excuse me, I need to set a breakpoint there. Otherwise, nothing came out. Okay, so go back to the file set and have better set a breakpoint here. So I need to restart, continue the code again. Alright, so and this time I will see the intersection is there here, and I'd like to add another one. Okay, so probably I will add the bear function. So bear and triangular. So this time I select triangular first, bear second, click on intersection again, bear function. So up to this point, I hit the element. So FS1 is still again triangular. The second FSS is the bear. I hit the element key. Came to here. Came to this line. You see, it's no change. So we came to this so-called operated function right here. So later on, you can use this ampersand symbol to represent intersection. That the code is much more readable. So in fact, behind this operator still, we still need to extension and intersection operator and supply F1 and F2 for this guy, for this binary operator for this set. So we will create a binary operator for this set, send it back to the caller. So invoke the initial constructor step by step. Then binary operator for this set. All right, let me dip this function call in debug. All right, come to this point. F10. See? So create file set has been ready there. And so add another tree node there. All right, so it's working. See right here. It's if a guy change the parameters of the triangular file set, and we will see how about the left. Changing to proper 5. Enter. So everything has been changed accordingly. All right. So that is so-called operated operator. So similarly, what we need is that we need what? We need to have the union, right? Union. We kind of use vertical bar operator. Union. This is union. So again, similar intersection, not intersection. Called union, right? Union operate. And how about scale and the cut operate? Okay, take a look at this one. We try to specify cut. This is a cut overloaded. Is a cut. Right? But cut is not a binary operator file set, right? The result should be unary operator file set. But for the C# programming, it's a binary operator. So take two arguments. But the first argument is not fuzzy set. The first argument should be a double. But the second one should be the fuzzy set, F1. So we are not going to return a binary, although this operation is a binary operation. Okay, although this is a binary operation, but the result is not a binary operator file set. The result instead is a unary, right? Unary operator file set. UNAR, no, you do not have this case. Okay. Yeah, okay. Yeah, we have. So the return type is not a binary operator file set. Return type is a unary operator file set. And what we need is that we have Okay, take a look at this function argument. Fs unary operator for this, right? So, what kind of unary operator I said we could have? Cut, right? Cut. Value, okay, value cut operator. Okay. Do we need to have value? No, we do not have. Okay, so the I think you guys did not special a parameterized cut operator. This cut operator is a unary operator, right? But user needed to specify a value, a cut value. So right now we cannot do anything, right? That means your class design is not complete. So let's go back to the cut. I think probably most of the students have this kind of problem. I'm not sure if you cut unary value cut, called value cut operator. Okay, it has cut parameter. You have cut parameters, but it's randomly assigned. What? Good point. 我会跟你讲怎么在下一层还可以让 user specify。那有点复杂，那个稍微有点复杂。但是 idea 不管 programmer 里头你要让它是所以这里头概念就是说 ，OK, it's okay because we do have a cut parameters right there, right? But you need to specify your constructor, ask that value. Otherwise, you cannot just randomly assign it. Well, initially it's randomly assigned, okay? But if a user specifically ask a value, then you need to provide the value, okay? So right now it's randomly assigned. It is okay. It's okay. So randomly assigned, but the user cannot do anything, right? So in this case, we will do what? We will provide another constructor that the user chooses it. So we have double, and then so PAR. So in this case, user can define because we need a when we inference for this a rule, we need to invoke this constructor. So I simply added this constructor PAR. Then I can do that. All right. So in this case, I kind of overloaded this operator. So in this case, I simply invoke a second constructor. I put cut value there. Cut value. Invoke another constructor that will do, and this one should be F1. Okay, so this is the cut operator. What kind of thing we need? We have it. Okay, we need to add another property of the fuzzy set. So now it's a generic fuzzy set, right? So about the property there, we have unit. So we add another property. The property is called public. Double max degree, and it should be overridden. Maximum degree, right? So we simply provide the getter return what? So far, I did not say anything. Okay, I simply add in the top class called fuzzy set, right? Fuzzy set has a property called maximum degree. If you are Gaussian fuzzy set, suppose you are Gaussian fuzzy set, right? If you are Gaussian fuzzy set, you need to override it directly without any confusion, just to return the value, right? So since this is a Gaussian fuzzy set inherit from the fuzzy set, right? So I can override which one? This property, maximum degree. And then your maximum degree is what? Okay, it's a so-called lambda expression. If you are not familiar with lambda correction, well, never mind. You just simply prepare the same skeleton of this getter function, get. You will override maximum degree. What kind of value? Do you need to check the value from the lower bound to upper bound? No. You simply return 1.0, right? That is the Gaussian fuzzy set because it's symmetric. It's a primary fuzzy set. So you know the maximum degree should be 1.0. But how about a general one? How about a general fuzzy set? This is the general fuzzy set, right? Sometimes it is generated from intersection, right? The maximum degree we need to check each instance point by point. Okay, all right. So the general fuzzy set, you need to search for all points. And because you have series, right? You have series ready for you, so you need to go through all the points, just like what? Like your update series. You see, you have update series, right? So you need to go through everything. Suppose that the points has been instantiated. Okay, similar x, right? Go through everything. So you have y get membership grid, right? So you are not going to update series at all. You simply well, the code will be different. Sorry about that. If the series none equal none, that means it has been instantiated. Because later on we will, if it is none, we will update, call update series. Update series to create a series, okay? So right now the series has been complete. Then what you should see? You see the series has what? Has well, let me check. Do we have y values? Members. It's a string. Okay, no. Series has points. Alright, points. Do we have y values? No, all points. Okay, all points. Points is a data point, so-called data point collection. Okay, so what we can do is that for each data point, you need to know the data type of each instance. We call it a P in the series points. So we look through each point, right? Update. Why I do not have update series? Yep. Okay, because we have problem. The IntelliSense has problem. So we have pattern. Make sure this die has been cleared. We have another one. So okay, so we check the series. If it is none, then we update. So update will instantiate the series. And then we check each point and take a look at P property. There's a y value, y values. And since Microsoft chart can deal with so-called Gantt chart, and Gantt chart has two y values. So y value is an array, anyway, it's an array. But you know, since right now we just have y value for each point, so we can use y value zeros. That means the degree, the membership degree, anyway. So in this point, because we want to return a maximum degree, right? So we have double max somehow. Initially set to what? Double. Each data type has been supported by a class defined in the Dante framework. So if you put a dot behind each built-in data type, it will pop out a lot of available utility function for you. Maximum value, no, we put in the minimum value, right? So we kind of check if the the uh, the y value is greater than max, then max will be updated by p dot the point p y values array, the zeros. Okay, that's it. We just loop through each point, and if the y value, that means the memory degree is larger than the current maximum value, the maximum is updated anyway somehow. So we make this complete. All right? Okay, send right here. So back to our using the, okay, give me another probably 10 minutes, I will wrap it up. If I can complete it, I will prepare a video tab to cover the rest of it. Okay, so let us go back to the press right here. So we add a rule, right? And then, so in this time, add a rule. So once user click on this button, click on this inference, right? Click on this inference. Then we will construct a rule set. Somehow rule set, because we have a rule class ready. And inference is that use the condition to invoke each rule, right? Okay. So what we need is that during the inference. Okay, during the inference. So we try to inference. Then we will create rule list. So we need to prepare, because we do not have an upper class called mundane fuzzy inference system anyway. So those stuff have been kept in the form. It's not good, but so far we just want to test the inference correctness, so we can do that right here. So we prepare a list. Fuzzy, if then fuzzy rule, if then fuzzy rule. So we call rules, and we need to initialize it to get this list object ready. So, so that is about a rule, right? So rule is DGV rules, data grid view, that rows, right? Each rows. And as you can see, we can, for each data grid v data grid view rows. So we have row in. It's a kind of new statement. I mean, you need to get familiar with it, because what we want just that we need to look through each row. We are not going to change anything there, so we can use for each to easily fetch each item or collection anyway. So we have R ready, right? And R, then so we see it for each row. So R dot cells. The zeros should be the you see we have put the fuzzy set behind the tag, right? So we know it's a fuzzy set, so we can cast it back. So we have fuzzy set zeros ready. Zeros fuzzy ready. Okay. And for each row, we might prepare if then fuzzy rule, if then fuzzy rule, rule, right? And then we might have list fuzzy set ant new. So programming wise, we need to go through all the cells, okay? So one by one anyway. So each row definitely will be create one rule, right? And before we could create one rule, we need to prepare antecedent, but we do not know antecedent. So It's a little bit troublesome, but again, we can do that. So we can for int I to 0, I small than r dot sales. Since sales is a collection, so there is always a count, but -1 because the last column by default should be the output fuzzy set, right? So that is the idea. So we kind of fetch the ith column, and then we cast it back to the fuzzy set. So antecedent ant is a list, so we can have it. You can use add. So add a fuzzy set to the antecedent. And how about the conclusion? Well, I've just put in here. Conclusion we do not do. Okay, fine. I keep using another so-called block local variable for you. GON anyway. Conclusion, right? And how about the conclusion fuzzy set? GON equal what? Cast fuzzy set on what? On r dot sales. The last column. Last column shows r dot sales dot count -1. Fuzzy set sales. No, it's a cell. The fuzzy set has been put in tag. Dot tag. All right, just figure it out. I mean, because each row, except the last column, they should be the what? Should be the antecedent part. So once I have an end conclusion ready, so I can instantiate the rule. A rule, a rule, new. If the fuzzy set rule, right? Antecedent, right? Antecedent and conclusion, GON. Okay, complete. And eventually, since you need to inference all the rule, right? So all the rule needed to be, the rest needed to be kept in somewhere. So I put in rules there. So in this case, rules need to clear first. And then once the rule is ready, so rules add a rule. So we guarantee when this button is clicked, each row has been created a rule object, and the rule object has added to the rules. So all the rules has been here. Then you need to get condition. So similarly, I mean condition, you need to check it from where? From this data grid view. From this data grid view anyway. From this data grid view. Okay. And probably the condition outside. I mean outside because we have rules there, right? So we can have a list of fuzzy set. Suppose it's a fuzzy set. I think I will wrap it up. Conclusion, GON, condition, DITL, conditions. Again, it's a list. So similarly, you need to prepare condition there. Okay, get condition somehow, and then inference. All right. We need to anyway end up on today's lab. I will make a video tab for the rest of work somehow to show you how to do that. So for assignment 5, at least we need to prepare fuzzyIfThenRule, and we should exercise about using the operator fuzzy to inference the result back to the user. I think this is the goal of assignment 5. So I will prepare a video tab for the rest of the instruction. Sorry about the overtime. Okay, all right. So that's it. And about the class.